Well, Tapan asked me to provide some information on a couple of projects that I either been leading or participating in that were investigating somehow the effect of cover cropping on the water side, but also in the new project on pistachio, we are trying to measure and document the effect of winter cover cropping on the radiation balance and water productivity in pistachio. I would like to provide a little bit of context first, saying that winter cover cropping has been somehow emerged in the last several years as a sustainable agricultural management practice. But anyway, the level of adoption is still pretty low, and especially is low in the western state of the US, where water is a big question mark, and especially we've been facing several years of drought, water restriction, and now Sigma, so we really don't know what's going to happen in the near future. Anyway, it appears that by 2019, this Soil Health Institute somehow estimated the level of adoption of winter cover cropping, and it was less than 5% of the western cropland in California. I would say that talking with a lot of growers, the main question is the lack of accurate information on water-related implication of cover crops. So how much it takes to establish and maintain, and what are actually the cost and benefit of winter cover cropping. There's a lot of research going on soil, microbial activities, and a lot other on soil health, the stability of aggregates and soil related aspect. But when it comes to water, there's still a lot of questions. Now, in California's Central Valley, some progressive growers have tested this over the years on multiple locations. One of the things that, there's always confusion, because when we talk about cover crop, some people consider, cover crop over the course of the entire year. Here in California, we cannot do that. We have to concentrate on winter cover crops, right? And so on a normal basis, they grow during period of low evaporative demand, and then they are terminated by the end of March or beginning of April, when the water demand or evaporative demand increases. But also they grown most of the time in period where the rainfall is the greatest. So I would say the period would be October, November to February, March. And then the timing of initiation and termination is pretty important. The potential mechanisms of actions are somehow depicted in this picture here. You got on the right side the clean cultivated ground, and on the left side the cover crop ground. So several articles somehow documented increased infiltration of water into the soil, also some cooler soil surface because of the mulching effect during the summer months, but also some collection of dew and fog that percolates near the soil surface and infiltrates into the soil. But there's also on the other side, the question mark is how much the cover crop, which is green active vegetation, transpires. So how much of that water infiltrated this store is then consumed by transpiration. In the opposite situation, you got soil evaporation from the soil surface, and you got increased soil surface temperature because the sun hits the soil, especially in the non-cover, in the raw minerals. But also there's, in some soil, heavy soil, there's soil compaction, sealing, and so that water, even if you have a small amount of water, that water runs off pretty fast. There's also lower soil infiltration. So these are basically what has been documented in the recent research. Here's a picture of the conventional winter fallowed and the winter cover crop in annual crops. Again, here a little bit of again the mechanism one versus the other. What happens in so one of the question is how long it takes to generate, the benefits of the cover crop, and this question is still unanswered. The medium and long-term benefit of winter cover cropping have been documented by several articles in terms of soil quality, better aggregation, better infiltration, better porosity into the soil, increased soil moisture infiltration and storage, less soil surface sealing and crusting, and improved soil health indicators. So those are being all somehow worked and addressed. Water quality and quantity is also somehow being documented in terms of soil erosion and control, and also effectiveness in leaching of salt if you have a winter cover crop relative to clean cultivated soil. And so the same amount of water is probably more effective in flushing out the salt accumulating over the past irrigation season. So there's a lot of potential benefits that are anticipated for winter cover cropping, but really in California, in the extremely variable climate and weather condition, we really need concrete information and also somehow an assessment of the cost and benefit that are associated with this practice. So I was lucky to participate in a previous research. This was led by Jeff Mitchell at UC Davis, but had a bunch of expertise on the team. And we did, we somehow measure the soil moisture and evapotranspiration, a bunch of sites across the Central Valley of California. Here are a few sites that were somehow included in this project, and this was done on processing tomato and almonds, all right? And so what we noticed, this has been published in California Agriculture in 2021. You can see here the citation of the article. What we noticed that across the Central Valley, there were negligible differences in soil moisture in clean cultivated versus cover crop, and this was done across 2017, 18, and 19. Now, the soil, the bare soil, loses water by evapotranspiration. In some locations, lose even more water than cover crop. So I don't think we can really generalize things at this point. So it really is site-specific situation. It depends on the type of soil. It depends on the weather. And so here is an example. We did this measurement of evapotranspiration in Davis on a cover crop versus a clean cultivated bare ground plot. And we noticed that the difference you see here is the control, which is the clean cultivated, versus the winter cover crop. Over the course of the winter, the difference was 0.12 inches of water. So a slightly more evapotranspiration, but it was very, very minimal. At Davis, it was 0.12, and in 5 points was 0.7 inches. So this difference is pretty insignificant in comparison with the potential benefit. When we evaluated so this was a seasonal evapotranspiration of the two systems, compared. When we evaluated the biweekly evapotranspiration in Davis, we saw that the clean cultivated was losing during winter time, during rainfall time, was losing more water than the cover crop plots. And when we did the same in 5 points, where the weather is drier, we saw that, of course, in a drier climate, the cover crop area was losing a little bit more water. but the measurement were probably accounting also for the amount of water that was trapped from fog and dew. So not all that water that we measure as evapotranspiration came from the water stored into the soil. And so this is a refinement that we should probably do and measure also the amount of fog and dew that is trapped. And so that's another potential benefit. Now, moving to the new research project on winter cover cropping in pistachio, there were a couple of motivation behind. First of all, the cover cropping, winter cover cropping is being promoted, encouraged by state agencies and federal agencies like NRCS and CDFA with Healthy Soil through climate smart financial incentives, so funding to growers in order to improve soil health and mitigate climate variability change. So there were, recent study that documented the beneficial effect of our rhizosphere ecology, so what happens under the soil for the soil microbial population and community and habitat, and also the root health, right? But there was, when we did this literature survey, there was no information on the effect of winter cover cropping during the active growing period and during the summer on what happens in terms of radiation balance. So light comes into the orchard and we don't know what happens. Is reflected back, is transmitted down. So we wanted to investigate this radiation balance and see whether this cover crop area and row middle somehow affect the light interception in pistachio tree. So the question that we got from several growers is, can the cover crop vegetation and the residue after the cover crop is terminated allow better light use efficiency? So the incoming light can be recaptured partially by reflection, as a result of reflection by this yellow colored row middles. And also the other question is this bringing, this cover crop, winter cover crop is somehow as a cost to establish, mow, and do all this practice into the field. It leads to some economic water productivity. That means more yield per unit of water evapotranspired. So those were the two questions that were mainly asked by growers. So this is what an example of a young orchard near Davis in Yolo County. We got a lot of, it was actually, originally was a cover crop mix, and then I think it evolved over time with as a native vegetation. But this is it reached this tall and then is mowed by the end of March, and the residue are left onto the row middle. Of course, in Davis, it rains quite a bit, more than in the Central Valley, in the San Joaquin Valley. And this is the way it looks after the mowing is done. This is an example how is it done in the Northern California, Northern Sacramento Valley. So what we did in 2022, we established this field trial in a mature micro-irrigated orchard, and we did it, replicated plots with, you can see cover crop and clean cultivated. So I tried to put here, we did it for two different type of pruning. What we call rooftop is one way of pruning pistachio tree, and tabletop is when they have the flat topping, because some of the growers say, oh, what if I do a different type of pruning? There's more light penetration. Out of that light, what happens if I have a cover crop area? So we wanted to collect field data to document comparative information on how this winter cover crop and this inactive vegetation left on the ground might affect reflection of the total light, but also the partition of this incoming radiation. So the radiation that comes into the orchard has two main components. One is photosynthetically active, so PAR, and the other one is near infrared. The near infrared generates heat, and the heat generates a little bit more water use, but it's not very beneficial because it doesn't generate carbohydrates assimilation. So we wanted to see, the incoming partition. So let's say the partition between PAR and near infrared of the incoming radiation, and also the partition of the reflected radiation between near infrared and PAR. So basically, there's incoming short wave radiation that gets onto the raw middle and then gets reflected back. So when we established this, basically during summer, late spring and summer, the raw middle looked like this picture here. So yellow, bright yellow, and of course it has a different reflectivity than the bare ground, and this we wanted to see whether it's beneficial or not. So these are our hypotheses and the possible mechanism where that improving light penetration and distribution within the tree canopy, up to 30 to 40% more light interception by the trees, but it depends what type of light. If it's only near infrared, then it's not probably beneficial. It's just generating more evapotranspiration, right? So wanted to see also whether there's increased photosynthetic active surface by the tree and better a more net CO2 assimilation per unit of water evapotranspired. Also want to see what happens in the below the soil surface if there's more soil oxygen in cover crop areas, and that means better root activity and improved uptake of nutrients also. And also we want to see whether this water that gets infiltrated and stored then is more converted to transpiration rather than soil evaporation. And so this means that if this happens, then we have better water productivity, more productive, more, let's say, carbohydrates per unit. So we try to explain the mechanism of operation in this two picture. When you have a clean cultivated ground, orchard floor, the light that gets to the soil surface gets transmitted below, and that generates energy increase, and that energy, if the soil is wet, generates soil evaporation. Here is like a mulching, right? And so the incoming light gets transmitted very little and gets bounced back in all the direction, and among the direction are also the lower canopy. So when we tested this in commercial orchard at Nichols Farm, after 3 years, he noticed that there were like more nuts in the lower part of the canopy and bigger nuts. In the clean cultivated plot, there was more nuts in the top part of the canopy, there were small nuts, but this is what he reported. We haven't done measurement in his field. So also there might be a higher microbial breakdown of the crop residue. So we did measurement before starting this project at Kearney. We did measurement in 2 commercial orchards. One was on bare ground at Nichols Farm in Hanford, and the other one was in Coalinga. This was managed by John Gabart at that time, and this was at a cover crop. And we saw that the net radiation in the cover crop block was higher than but that doesn't necessarily mean that that light get re-intercepted. So this orchard was alternating much less than this orchard, and they were both Kerman on Pioneer Gold 1, but this orchard was hitting 5,000 pounds per acre every single year. So we saw also less alternation in the bearing. When we did additional measurement, don't look at all this number in between, just look at here, the albedo is what matters. So the albedo in cover crops, in a cover crop orchard is higher than in a clean cultivated ground. And that was the reason why we put together this project at Kearney in more controlled situation and replicated trial where we wanted to see the effect. Now, this is the way it looks. You're welcome to visit the site. We seeded in 2022 the cover crop. I think it was like beginning of January. And so we had a good stand establishment. It was about 4 feet high. And when he seeded, we mowed it and left the residue on the ground. And this is the clean cultivated. We clean the area in the clean cultivated as much as possible. And this is another picture of the clean cultivated. This is the way it looked this winter after seeding again the cover crop. Yeah, this is the way it looked like a couple of weeks ago after we reseeded cover crop slightly wider. And as a good stand establishment with this rain of this year, it's probably is going to be a very good cover crop, very dense cover crop. And this is the way we are measuring the radiation. So there's one sensor that measured the total radiation, another sensor that is measuring PAR, and by the difference between the two, we estimate the near infrared. So this is what hangs low in the, looking down to the ground, but there's also similar two sensor on top of the canopy. So we want to see the incoming and then reflected back. This year, we are reinforcing the data collection, but I wanted to show you some results from last year. I want to tell you before showing the results that orchard, that Kearney, was sprinkler irrigated. This is not representing the reality. But when we started working on this, we didn't have the time to shift to drip. And also we didn't want to shift to drip because the root, it was kind of mature orchard. But having a micro sprinkler irrigated orchard, it means that you get most of the areas that was wet. Remember this. So when we evaluated the data, here you can see a rooftop prune tree like this. And so you can see that the cover crop plot had a higher reflectivity in PAR and higher reflectivity in near infrared, and this is the ratio. But look, the real number that you have to look at are the albedo. And so albedo in the PAR area, it's higher than the clean cultivated plot, and the albedo in the near infrared. So both of them are reflected back, all right? Now, this is reflectivity is basically consider only the reflection in one incident angle. Albedo consider the reflection across all, integrated across all the angles. So look at the albedo, because the reflectivity refers only to noon, solar noon, and that's not enough. You have to see over the course of the day what is the reflection of the radiation. In flat top prunes, we had similar results, and you can see there's less reflectivity in PAR, less reflectivity in near. So the pruning affects the amount of light that comes into the orchard, but also the cover crop affects the lights reflected back. So in both cases, there were more reflection in the cover crop than in the clean cultivated. This is my last slide. The ratio of near infrared albedo to PAR albedo is 25-40%. There's more near infrared reflect in these conditions. And then we're all wet, so it was not beneficial the way it was. Then we said, maybe the wetting of the row middle affected the partition, which was the case. So we stopped irrigation for 38 days before harvest, and that partition between near infrared and PAR changed towards PAR. So this year, we are removing the fan jet, and we're putting the sprinkler irrigation, the dual drip, and we will see and document what happens. But so far, I would say there's more reflection of total light, and I would say there's a possibility that the dry condition of the row middle that you have in drip irrigated field move all the partition, the partition in a beneficial way towards PAR. So this is an ongoing project. We'll be able to document a little bit more to the next meeting. Thank you so much.
All right, thank you. Any quick questions? Yeah, go ahead. I have my sorry.
Thank you. One of the challenges of adoption in the almond industry is the thought that cover crops let's see, aren't as effective against frost protection. I know there's research being done that's saying that might not be the case, but do you have any opinions, or is any of your research capturing any kind of ambient warmth or those kinds of metrics?
Yeah, we are measuring the temperature of the ground and the temperature of the canopy when the canopy is there. But so I'll be able to give you more information. But also, I think that a lot of this evaluation that we heard about, they don't really consider the difference that you have from the weather station with respect to the orchard. The orchard normally has a cooler temperature than the, or hotter temperature. It depends on the period. But anyway, we are measuring the temperature in cover crop versus bare ground. But I saw that there might be a detrimental effect, but pistachio somehow skipped the frost because it started much later. We submitted another proposal to the CDFA to work to apply this concept for almonds and wine grapes. And so if they happen to get funded, that might be research in the next 3 years. Yeah.
Okay, thank you.
Thank you so much.